Welcome to Senior High School Mathematics. Let us have definition and equation of a circle under pre-calculus, Quarter 1, Week 1, based on curriculum implementation and learning management matrix for K-12's most essential learning competencies. Here are our learning competencies. Define a circle and determine the standard form of the equation of the circle. Before we continue, let us ponder on this. Our task must be to free ourselves by widening our circle of compassion, to embrace all living creatures and the whole of nature and its beauty. This is by Albert Einstein. From the previous discussion, we learned that the circle is a special type of ellipse. It is formed when the plane that intersects a double right circular cone is perpendicular to the axis. This time, let us have an explicit definition of a circle. A circle is the set of all points on a plane that are equidistant from a fixed point on the plane. The fixed point is called the center, and the distance from the center to any point of the circle is called the radius. Let the center of a circle be at the fixed point CHK, and let the radius be equal to r. Then, if any point with coordinates xy is on the circle, the distance from C to P is equal to r. This condition requires that the square root of x minus h squared plus y minus k squared is equal to r, using the distance formula between any 2 points. Squaring both sides, we get x minus h squared plus y minus k squared is equal to r squared. The formula x minus h squared plus y minus k squared equals r squared shows the coordinates of the center and the length of the radius, and consequently is sometimes called the center radius form of the equation of a circle. Conversely, the graph of an equation of the form x minus h squared plus y minus k squared equals r squared is a circle with center at hk and radius equal to r. This fact is evident since the equation is satisfied by and only by points whose distance from hk is r. Hence, it is an easy task to write the equation of a circle whose center and radius are known, or to draw the circle whose equation is expressed in the form x minus h squared plus y minus k squared equals r squared. If the center of the circle is at the origin, that is h equals 0, k equals 0, and the radius is r, its equation is represented by x squared plus y squared equals r squared. Let us have some examples. If the center of the circle is at negative 1, 4, and the radius is 3 units, write the equation in standard form. So this time, we know the coordinates of the center and the length of the radius. It is easy to write the equation of the circle in standard form by substituting the coordinates of the center to hk and the length of the radius to r in the standard form of the equation. That is x minus h squared plus y minus k squared equals r squared. Substituting, we have x minus negative 1 squared plus y minus 4 squared equals 3 squared. Then we have the equation of the circle in standard form as x plus 1 squared plus y minus 4 squared equals 9. The standard form of the equation of the circle can be presented in another way. That is by squaring the binomials on the left-hand side of the equation and collecting terms. Thus, from x minus h squared plus y minus k squared equals r squared. Squaring the binomials, we get x squared minus 2hx plus h squared plus y squared minus 2ky plus k squared equals r squared. Rewriting, we have x squared plus y squared minus 2hx minus 2ky plus h squared plus k squared minus r squared equals 0. The last equation is of the form x squared plus y squared plus dx plus ey plus f equals 0. This is called the general form of the equation of a circle. Conversely, an equation of the form x squared plus y squared plus dx plus ey plus f equals 0 can be reduced to the center radius form or the standard form by the simple use of completing the squares in the x terms and the y terms. This is illustrated in the following examples. Change the equation x squared plus y squared minus 14x plus 12y minus 36 equals 0 to standard form. So we're going to collect the x terms and the y terms, leaving spaces for the terms to be added in completing the squares. So we have x squared minus 14x plus y squared plus 12y equals 36. To complete the square in x squared minus 14x, we divide the coefficient of x by 2 and then square the result. That is negative 14 divided by 2, negative 7. Negative 7 squared is 49. And that must be done also in the y squared plus 12y. So 12 divided by 2 is 6. Square, that's 36. On the right hand side of the equation, we also need to add 49 and 36. So now we have x squared plus 14x plus 49 plus y squared plus 12y plus 36 equals 121. And then writing the perfect square trinomials as a square of binomial, then we have x minus 7 squared plus y plus 6 squared equals 121. And this is the standard form of the equation. Next, let us have example number 3. Find the center and radius of the circle. So we use the same method in identifying the center and the length of the radius of the circle. First, let us divide all terms of the equation by 9. Then we'll get x squared plus y squared minus 4x plus 2y equals 9. Collect the x terms and the y terms, leaving spaces for the terms to be added. And then complete the square. So we have x squared minus 4x plus 4 plus y squared plus 2y plus 1. Then we also need to add plus 4 and plus 1 to the right hand side of the equation. So we have x squared minus 4x plus 4 plus y squared plus 2y plus 1 equals 14. Rewriting the square trinomials in the left hand side of the equation as square of binomials, we have x minus 2 squared plus y plus 1 squared equals 14. Therefore, the center is at 2, negative 1, and the radius is equal to the square root of 14 units. Example number 4. The circle with center at negative 2, 3 is tangent to the x-axis. Write the equation of the circle in standard form. This time, let us have the circle plotted on a rectangular coordinate system. So it is tangent to the x-axis with center at negative 2, 3, so that we can get the length of the radius, and the radius is perpendicular to the x-axis at the point negative 2, 0. So the radius will be the distance between the center negative 2, 3 and the point negative 2, 0, and that is equal to 3. So we substitute the coordinates of the center and the length of the radius to the standard form of the equation of the circle. We get x plus 2 squared plus y minus 3 squared equals 9. In some cases, both the standard form and the general form of the equation of the circle can be useful in finding its equation. A circle can be passed through 3 points which are not on a straight line. This can be illustrated in the next example. Example number 5. Find the equation of the circle which passes through the points P, 1, negative 2, Q, 5, 4, and R, 10, 5. We're going to use the general form of the equation of the circle, that is x squared plus y squared plus dx plus ey plus f equals 0. And then we're going to substitute the coordinates of the given points to x and y, producing 3 equations in 3 variables d, e, and f. Let us do that with point P. So substitute 1 to x and negative 2 to y. Will have 1 plus 4 plus d minus 2e plus f equals 0. Let us call this our equation 1. Then let us substitute the coordinates of point Q to the general form of the equation. We have 25 plus 16 plus 5d plus 4e plus f equals 0. Let us call this our equation 2. Let's do the same with coordinates of point R. That will be 100 plus 25 plus 10d plus 5e plus f equals 0. And this will be our equation 3. Now we have 3 equations in 3 variables. We're going to solve for these 3 equations simultaneously to get the values of d, e, and f. And then we're going to plug these values in the general form of the equation so that we will have the equation of the circle. First, let us eliminate the variable f by subtracting equation 2 minus equation 1. Doing that, we get 36 plus 4d plus 6e equals 0. Let us call this our equation 4. Let us use another pair of equations in 1, 2, 3 to eliminate f. Let us use equation 3 minus equation 2. Doing that, we have 84 plus 5d plus e equals 0. Let us call this our equation 5. Now we have reduced the 3 equations into 2 equations in 2 variables d and e. We're now going to solve this simultaneously to solve for d and e. To do that, let us eliminate e. We'll have equation 4 minus 6 times equation 5. Then we will have negative 468 minus 26d equals 0. Solving for d, we get d equals negative 18. Now we substitute the value of d to either equation 4 or 5 to get the value of e. Doing that, we get e equals 6. Then we choose from equations 1, 2, and 3 and substitute the values of D and E to get the value of F. Doing that, we get F equals 25. Now we can substitute these values of D, E, and F to the general form of the equation, and we'll have the equation of the circle as x squared plus y squared minus 18x plus 6y plus 25 equals 0. Let us have an alternative solution to this. In geometry, we learned that the perpendicular bisectors of two chords of a circle intersect at the center. So let us have the perpendicular bisector of the segment PQ, and we get 2x plus 3y equals 9. Next, let us get the perpendicular bisector of the segment QR. That will be 5x plus y equals 42. Solving these two equations simultaneously, we get x equals 9 and y equals negative 3. Therefore, the center of the circle is at 9, negative 3. Then we can choose from any points P, Q, and R and find the distance between the point and the center. That will be our radius. Let us choose point P. So PC, using the distance between 2 points formula, PC is equal to the square root of 9 minus 1 squared plus negative 3 plus 2 squared. We get PC is equal to the square root of 65. So we substitute the coordinates of the center and the length of the radius to the standard form of the equation of the circle. We'll get x minus 9 squared plus y plus 3 squared equals 65. Next example. A circle is tangent to the line 2x minus y plus 1 equals 0 at the point 2, 5, and the center is on the line x plus y equals 9. Find the equation of the circle. Let us do this by drawing our figure that would help us in solving the problem. So we have the rectangular coordinate system. The circle is tangent to the line 2x minus y plus 1 equals 0 at point 2, 5. We know that the line containing the radius of the circle is perpendicular to the tangent line. So we need to get the equation of the line containing the radius. Also, the center of the circle is on the line x plus y equals 9. So to get the coordinates of the center, we will solve the equation x plus y equals 9 and the equation of the line containing the radius simultaneously. Let us find the equation of the line containing the radius. To do that, we use the tangent line 2x minus y plus 1 equals 0. We get the slope, and the slope of the line containing the radius will be the negative reciprocal of the slope of the tangent line. So we have x plus 2y equals 12. The negative reciprocal of the slope of the tangent line and the points 2, 5 using the point slope form. So we get x plus 2y equals 12. And then we're going to solve this simultaneously with the line x plus y equals 9 to get the coordinates of the center of the circle. Subtracting the two equations, we get y equals 3, and substituting the value of y to either equation, we get x equals 6. Therefore, the center of the circle is at 6, 3. Now we need to get the length of the radius. We're going to use the distance between 2 points formula, and we'll have r squared is equal to 6 minus 2 squared plus 3 minus 5 squared. So r squared is equal to 20. Then we have the equation of the circle as x minus 6 squared plus y minus 3 squared equals 20. For more exercises on this topic, download from the link given on the description of this video. That is all. Thank you for watching. Please subscribe for more math lessons.